Hello and welcome to another video, not necessarily a tutorial today, but this time we're gonna do a Unreal versus Unity episode. Okay, a lot of people are doing that. I think it doesn't hurt for us to also do one. But of course, which one is better is mostly personal opinion, right? So it's really hard to say which one is better because there is always arguments between each party, right? It's not a black and white judgment, and I think it's mostly personal opinion, and oftentimes one party doesn't know the other one enough to be able to judge on it anyways. But it doesn't hurt for us to do a simple comparison, right? For like a beginner level, I think it's helpful to give you guys a preview on like how does the two engine feels like with some simple game development. And today I'm gonna do a bowling game in both engines, just to show beginners, right? If you wanted to have a taste of how does those two engines feels like, you can follow the video, right, and do the exercise, and decide it for yourself, right? Whichever one you feel better working with, use that one. Okay, don't listen to anyone who tells you one is better than the other. Most of the opinions, including mine, is really biased. Okay, so let's go ahead and do the thing. Okay, so let me start with Unreal. Okay, I'm gonna go ahead and create a game here. Next, blank. Next, this is something like you can either choose super easy fundamental rookie level programming, or C++, which is the hardest language to use in the universe. No one likes C++, even C++ users, right? There's a joke which says that I think there's a company who told the creator of C++ that one day they were complaining that we don't like C++, even it's the only thing works. Okay, anyway, so there's a debate on either C++ should be used as the actual scripting language for the game engine, but I think Epic Game choose that for a reason, right? For this one language and rule them all, everything is transparent. There is no hiccups if you all use the same language under the hood. So I think that they have their reasons, but also they do provide blueprint to make things easier for beginners. Okay. All right, so I'm gonna go for blueprint first because it's easy, right? I'm gonna go for bowling games, and then create project. This should be really swift. Now this is also based on the your computer. Mine is 4 years old. I have the sixth generation CPU, so it's not the best CPU. It's i7, by the way. Okay, now I'm gonna go for file, new level, and then defaults. Now the way you navigate is right mouse button and use WSAD to look around, right? And I don't need anything else other than the lighting here, so I'm gonna grab that floor and just hit delete button on the keyboard by clicking on it and delete, right? I'm gonna start creating my little game mechanics. Okay, for the bowling game, I need a bowling ball, and I need to define the direction that I can throw the ball, right? So I'm gonna right click here in the content browser. That's where you have all your assets. I'm gonna go ahead and create a blueprint class, and here I'm gonna use Pong. Pong, as you can see here, is an actor that can be possessed and receive inputs. That's what I want to have, receive inputs, right? Pong here, and I'm gonna call this guy BP as blueprint. Player Pong. Okay, save that by pressing Ctrl S and double click to open it. Now here is the editor for that particular blueprint. Blueprint is basically an entity you can throw into the level in here and to do something. And this is the editor. Now here we have the component, which will be able to add stuff, right? Add things like a visual representation or other things to this player Pong. So I'm gonna go ahead and click on the add component and choose. In this case, I need something to point. So I'm gonna search for cone. There's a cone we can add. Okay, for this cone, I'm also gonna lay it down and -90 by hitting the E button to go to rotation, and just drag it to rotate it. Okay, and then hit the R button to go to scale and stretch that to make it longer. Maybe move it forward a little bit. You know what? I'm gonna put it in the origin. That way its direction is going to be very easy to be recognized. Okay, that's good. Compile and save. To save my result, I'm going to add another thing, which is the ball. So sphere should be fun. I'm going to drag the sphere also to the default scene root and say attach. That way they're parallel, right? They're not underneath each other. I don't know why it's stretched 4 times on the Z, so I'm going to zero that out. Okay, so the idea is that we can use some coding to control the direction of this, right? And when we hit maybe left mouse button, the ball then will be shoot out towards the direction of this cone. Okay, that's the idea here. Let me rename that sphere by grabbing it and hit F2 and then name it a bowling ball. And this one will be named to pointer, right? Where is pointing? Okay. Now to start adding some game logic, I just need to go to the event graph. Okay, here that's where we write our code. Okay. Now when even in the event begin, or actually I'm going to do that in the. Actually, I can right click here and say mouse well, right, and then axis. This is going to give me the mouse well axis, right, which is how much you're moving the mouse well. And then I'm going to drag out the pointer. Oh, back here. Drag it out to the graph. I can use middle mouse button, right mouse button to move around, and the mouse wheel to zoom in and out. Okay, I'm going to say add local rotation. Okay, just drag out from the pointer and start typing. Add local rotation, and connect that tick, which is going to be called every frame or every time the game updates. It's going to call this function called add local rotation. A function is basically has some functionality, right? And it's adding local rotation to the pointer here, which if you go back to the viewport, that's this guy, right? Adding the rotation on the, let's say, go back to the viewport, you can see if you rotate it, it's on the x-axis. Actually, it's not. That's the local one. I need to add it on the world level, which is z-axis. Actually, that's the this axis. Okay, so I'm gonna right click here and say break or split structure pin, and that goes to the Z. Of course, we can add some extra things. I think I can drag out from here and type in a multiply, right, and or star here, and then float times float, and result that result goes to the rotation, right? And for that, I'm going to drag it out and then promote it to variable. For this variable, I'm going to call it pointer row speed, right? And compile and save it. I can give it a default value of 10. Okay, compile and save that. So what's happening now is for every tick, it's going to check how much the mouse wheel is moved, time that by 10, right? And then add that result as extra rotation, add it to the pointer. Okay, compile, save that, and then here I'm gonna go drag it over to here, right? And I don't have to rotate it. And also I need to give it a camera, otherwise there's nothing to look through. So I'm gonna add a camera here. Compile, save that, go to the viewport, grab the camera, drag it up and drag it back. We can also see that in here. So with that, I can easily see what's going on, right? Maybe a little bit further, a little bit higher too. Compile and save that. Okay, now to control it when I play the game, I can go to the details and search for auto possess player and change that to 0. So when the game starts, player 0, which is you, will be possessing this pawn, which will take inputs. When you use the mouse wheel, it's gonna, again, every tick, every updates, it's gonna use that value to update or adding offset to the rotation of the pointer on the z-axis. Go ahead and play this and see now when I rotate it, see it's changing, right? It's shaking, so there's something wrong. Let's take a look. Okay, let's go grab the bowling ball or pointer. Okay, tension Z. Let's see. Yeah, that should be it. So I guess we can play it, and then it looks to me that it's rolling in the other direction. So I guess we can try X. I might be wrong about that value though, so I'm gonna stop this. Okay, I'm gonna use the row in this case and get rid of that. Let's take a look. Okay, play that. Yeah, now that's going to the right direction. So now I'm able to, you know, determine the direction of the ball, right, where it's shooting. Cool. Okay, when that is done, then I want to move on to the next step, which is, you know, when I left click, I want to shoot the ball out. Okay. Now, first of all, the ball doesn't have to simulate physics. It's better to tell the pointer to not collide with anything. Otherwise, it's going to push the ball, right? So I'm going to go here with the pointer selected, go to the details panel and look for collision, which is somewhere here. I'm going to say collision will be no collision, and that will be good. For the ball, right, all I have to do is right click and say left mouse button. When left mouse button is pressed, what I want to do is grabbing the bowling ball and then set simulation physics to be true, so it's starting to simulate. You just drag it out and start tapping, right? And then we can add impulse. Okay, and connect that. You can see there's a calling execution pin here, right? So when you press the left mouse button, it's going to do this, and then it's going to do this. You can see this flow here. So first of all, it's going to turn on simulation for the bowling ball, and then it's going to add an impulse. Okay, so the impulse will be going towards the direction of the pointer. So I'm going to drag the pointer out, and then I'm going to say get up vector. Now up vector is its z vector. I believe that's where it's pointing. If I change that to object mode, maybe not. Let's take a look at that. It is z here, so I think that's z, but maybe we can change it later on if it doesn't do that. We can do the same trick, drag out from here and time a multiply, and this time vector times float, result goes to impulse, right? And we can even check on velocity change. So it's going to change the velocity despite how heavy the ball is. It's going to apply that as a actual velocity, and the amount will also be promoted to a variable here, right? We can then call this guy speed, okay, or slow speed. Okay, I'm gonna say compile, save, and change that to like 100. Okay, and let's see what we got. Play the game and then left click and see, oh, the ball is going forward, right? Nice. Okay, of course it's too small, so I'm gonna go to the slow speed and change that to maybe 5,000. Seems to be a better value here for a bowling ball. Oh, maybe that's too much. I guess 1,000. Compile and save that. Play it. Right? Now you can see it's also going towards the direction of the pointer, which is nice. Now I'm gonna build up the track for the bowling alley, right? It shouldn't be really hard. Just need to go ahead and drag things around. I was dragging in like a cube, right? And just move things around. So W is how you move, E is rotation, R is scale, right? That's how I did all these, right? Okay, move it. Okay, maybe longer. Okay, holding down Alt and drag to have a copy, shrink it, and I can make it the wall. Holding down Alt and drag out one more. Okay, and then I need the pins, right? So I'm gonna close that now. I'm gonna right click and create another thing, another blueprint class, and this time actor. Actor is gonna be the basic thing you can place in a scene. I'm gonna call this guy BP underscore pin for the pins. Open that. Okay, in the event graph. Oh, actually I need to add it a static mesh also. Okay, I'm gonna call this guy pin. I'll save that. In the pin, I'm gonna change that to a cylinder. Okay. Shape cylinder should be better than that, because it has the materials. Because the viewport, you can see that's how it looks like. I can make it longer, maybe shrink it. Okay. And for the pin, we just need to make sure that it's simulating physics. We can also do that by just checking this thing on. We can even define the mass in kilogram, how heavy it is. Okay, but let's just give it a try, right? I'm gonna drag this over now to the scene. I'm gonna create just those bunch of pins. Okay. Alrighty, and let's give it a try. Play the game, hit. And you can see the ball rolls forward, and then hit those guys. Now I think the ball maybe is not heavy, it's not fast enough. So I'm gonna grab that and press Ctrl E to open that editor for the BP player pound again. And here I'm gonna go select, or I can just change it here. Throw speed to 3000 maybe. You don't have to compile it or save it. If you just hit the play, it's gonna do both for you. Yeah, it needs to be stronger. That's too weak. 5000 I think is gonna be a proper value here actually. Alright, cool. Okay, now I need to have some way to count how many pins I have, hit down. So I'm gonna go create a little room for this. So maybe I can copy from there. Need to be wider here. Holding down Alt and drag it out to have a copy. I'm gonna shrink it, make it 90 degrees, just to create a little room in here. Okay. And then go down there and just have another copy, right? And that's what's happening in real life, right? You have something to take care of the pins. This is too low. Okay, I'm gonna drag that and make it higher. Okay, and maybe one more. Those are gonna be done by artists in like a 3D modeling package, right? We're just making it simpler by just do something like this. Okay, now I need to create another blueprint class, which is also actor, to count how many pins we have knocked down. So counter. Okay, and I'm gonna open that. And for this one, I'm gonna go add a box collision here. Okay, now scroll down to the very bottom with the box selected. We can click on the on component begin overlap. This one, and this is gonna bring me to the event graph, and this is gonna be called whenever something overlaps with it. The other actor I'm gonna check is child actor. Is or get class, right? And that has to equal to pin, right? It has to be a pin, so BP pin. If it is a pin, then we can do holding down B and click to create a branch. This branch basically says that if this is true, if this equals to that, which the class of the other actor, right, whatever that is overlapping with it, is having the same class type as BP pin. Class means type, right? So if they're the same thing, same type of things, or what I'm checking is if this is a pin, right? By checking its type and see if it is pin. If it is, then I'm gonna say, hey, this other actor, you're gonna destroy yourself. Okay, I'm gonna call destroy actor here on that actor, which will destroy that actor, and then I'm gonna add a number to the pin count. So I need a number for that. Okay, I'm gonna go ahead and add a variable. So here to the map blueprint part, I'm gonna go to variable part, hit the plus sign, and call this guy counter. And then the variable type will be an integer, which is a number that does not have a friction. And it's equals to 0 now. I'm gonna drag that out and say get counter. Oh, sorry, not get counter. Holding down Alt and drag it out to set it. Okay, and then I can holding down Control and drag it out to get it. And then I'm gonna add a integer plus 1. Or I should be able to just have that increment actually. But yeah, this is basically saying every time when there is, let me actually dock it in here so you can see. Every time when there's something overlapped, we get the type of that thing see if it is the type pin. If it is true, then we destroy that and we add this counter by 1 and set it. So the counter will become 1 bigger than before, right? Every time we have a new pin falling into, of course, the box in this case. Back here to the editor, I'm going to go ahead and drag that counter in here. Oh, you know what? Before I do that, I also need to have something to show me, right? So I'm going to add a text render and put it also. I don't want it to replace that. Yeah, I can just put it in here. Yeah, compile and save, right? So we have text render, and then in the viewport you can see it looks like that. I don't need to drag it out. I can position it later on in the editor. All I care about is the text will be called score column 0 for now, and then it's going to be aligned to the center. And other than that, I don't really worry too much. But the thing I need to do is now I can drag out the text renderer and say set text. Okay, and the text will be set to a new text. I'm going to set it to drag it out and say this is a text, right? So I'm going to drag that out and say to string to make it a string, and then I'm going to do append. Okay, I'm going to connect that to B, and for A, alt click to break that connection. I'm going to say score column that. Okay, and that goes to the value. There's going to be another conversion to convert string to text. Those are just, you know, some combination of number append with a score. So score, and then we got the number there, right? That's going to show score and then how many pieces we have, and that's going to convert it to a text, which will then be set to the text which is written in here. Okay, compile, save that, and then I'm going to drag this guy in and make it real big and rotate it -80, right? All right, I'm gonna drag it. I'm gonna make it close that. I'm gonna go to the component here and grab the box and drag the box down and make it narrower and maybe wider here, so there's no chance that any pin would skip it, right? For the score, I'm gonna grab the text render and drag it up so we can see the score in here maybe. All right, go ahead and play the game. Oh, I don't really see it. Probably need to bring it down even further. It can be anywhere, so maybe we put it here on the ground. That will be something we can do. Play that. Oh, you know what? The color is hard to see. And I guess, yeah, it's not that easy to see in there. So I guess we just make it stand still and then go there. And maybe we can tweak the camera. So I can grab the camera and drag it back a little bit more and play the game. Now I can see the score. Right, I got 1. Okay. The only thing I can do is restart. So should be easy. Go back to the player palm. Okay. Now we can say right mouse button. Okay, and then we can say load the map. Open level, maybe. Open level. And the level name will be the name of the new level here. We haven't saved it yet, so I'm gonna press Ctrl S here and save it as game. And copy that name here. And then in the here we just paste in the game we're loading. Just paste in game here, compile and save. Back here to our game, play again. Let's see if I do a better job this time. 3, 4, 5. Okay, I right click. You can see now I'm back to begin again, and I can try that one more time. Right, the cool thing here, and not the cool thing, but there's a bug here. You can keep on clicking to push it, right? Now it's very easy to fix in Unreal Engine. You just need to go here and say, I just want that to happen once, right? So I'm gonna say do once. Okay. And then I guess here, if we after we reopen level, we can reset the do once, so it's no longer locked. So this will make it only do once in this session. The next time we load a new level, we reset it so it becomes open again. Right? Go ahead and play this again. You can see it doesn't do that anymore, but when we right click, we can do it one more time. Okay? Yeah, it's that simple in Unreal. Just quickly, you can see in 25 minutes, including the introduction I did, is all I need to get this game up and rolling. Right, shoot out the ball and then, you know, get the scores. Of course, there are many things you can do, like maybe keep the score in a file or somewhere. Right, that's something else we can do. But, you know, let's just keep it simple. Alrighty, so that's how you do it in Unreal Engine Blueprint. If you're a beginner, if you don't like coding, this is perfect. You don't even need to write even one line of code, and you can do pretty much anything you want. From a professional programmer's point of view, it maybe is kind of like lazy and not the solution they would choose. But for beginners, for newbies, why not? Like, if you can just make a game real quick, and, you know, not having to deal with the pain of learning programming, you got Unreal covered. There's no parallel to this. Like, there are other plugins in Unity, but Blueprint is highly integrated with Unreal. It's part of it. It's the tool they use internally when they're developing their own game, like Fortnite. So there's no reason not to use Blueprint. Okay. All right. That's it. That's it for Unreal Engine's Blueprint. Let's move on to Unity. Okay. Minimize that. Alright, so for Unity, I'm gonna go add new, and I want to choose the high definition RP because I like pretty graphics. Bowling, ball, and then hit create. That should go ahead and create Unity. Yeah, Unity projects. So based on, again, how good your computer is, this may take a while, or this may take just a matter of you know, a few seconds. So you're gonna have to wait for just a little while for it to load the packages and stuff, especially when maybe it's for a high rendering pipeline. It looks a little slower. I don't know, but you have to hold on and wait for those things to finish, just like Unreal's loading screen. Okay. Let's just give it some time to load. Resolving some packages. Okay, we are almost there. Importing some default scenes, I guess. That's based on the hard drive. Like, sometimes I'm using a hard drive, traditional hard drive, so maybe it's just waking up. So that's why there's no progress here. Hopefully it's gonna load it soon. And normally Unity should be faster than Unreal when it comes to loading. I'm not sure why it's slow this time. Okay. Okay, now it's opening. Okay. When it comes to pricing, Unity costs nothing if you don't care about using this brighter UI and missing a few features from the Pro version. You're gonna have to pay if you want to use the Pro version, or your revenue is beyond something. I don't remember, a small number maybe. I don't remember that. But Unreal is like, you know, it's free until you make $1 million out of it, and you have all the features. Anyway, so I'm gonna go here, and I don't need that either. So I'm gonna go for File, New Scene, and I'm gonna start placing my stuff right away. So I'm gonna go for Game Object, 3D Object. I'm gonna look for, there's no cone, so I guess I use Cube. Okay, and I'm gonna drag it and make it longer. Okay, and this is gonna be my pointer. So grab the cube and type in pointer. The navigation here is Alt and left mouse button to rotate, middle mouse button to move around, and right mouse button to zoom in and out. Right, all those three operations need you to holding down the Alt button. You can also use that Unreal navigation, which is right mouse button and then WSAD, just like you're moving in the game. Okay, now I also need a new empty project, new empty object, and name this guy player, and then we drag the pointer to the player. Okay, I'm gonna zero out everything for the position of the pointer, so it's where the player is, right? Okay, and I also need another thing, which is the ball. So game object, 3D object, and then sphere. Drag that over to the player. Also zero out everything here in position to put it to where that is. And I guess I can make it a little bit bigger, maybe twice as big. Okay, now to turn on physics, I need to go here, add component, and then I'm gonna add a rigid body, and it's gonna be that. Okay, for the pointer, again, we want to disable collision, so there I think I can just click on that and then remove component. Okay, alrighty, now we need to really do some coding, so I'm gonna go grab the player and then add a component and then new script, and I'm gonna call this guy player control. Okay, and should be added in here any minute. Okay, double click to open that, and that's gonna open Visual Studio or whatever IDE you have. You probably need to install Visual Studio. There are some other IDEs, but Visual Studio is one of the ones that's quite good. Okay, so now we have Visual Studio. Okay, and then we can start typing in stuff. For the mouse wheel, I'm gonna say float mouse wheel move amount will be equals to input dot get axis, and then I need to know the name for the mouse wheel, which will be underneath edit, project settings, and then input manager axis, and you can look for mouse scroll wheel. I'm gonna copy that, and that's gonna be the text you have to put in here. Okay, so that's gonna give me how much the mouse mouse wheel has moved. Okay, and if mouse wheel move amount is not equal, question mark, exclamation mark, and equal means not equal. If it's not equal, then we have two curly bracket, which is gonna be what happens if this is true, right? If it is not 0, that means the mouse wheel is moved. We want to rotate the pointer, right? So we need to get a reference of the pointer. The easiest way is to say public game object pointer right? And then we can say pointer dot, and delete that gap here. Pointer dot transform dot rotate. Okay, and then we're rotating the transform. We need to have a vector. See, I'm not sure why it's not working here. Maybe I have typed in the wrong thing. Copy that. Yeah, that's pointer. Dot transform dot rotate. I just need to specify a angle to rotate. So I'm gonna say vector 3 dot up vector, rotate around the up vector, right? And then we just need to type in multiply with the amount we want to move, which is mouse wheel move amount. We can also multiply that with a speed, which we'll have to create. You can see this is basically how coding feels like. And also I need to basically have that delta time also involved, so that this is basically how much time that has been passed since last update. That way we have consistent speed. Okay, so speed then has to be created here. I'm gonna say public float speed. Okay, I can give it a default value like I don't know, 10, 100, because I'm using delta time, so this would be really slow maybe. Which reminds me, I should have done that in Unreal to add delta time. All right, cool. Save that, and back here to Unity, it's gonna compile it, right? I'm gonna clear that, and I'm gonna grab the player, and you can see now we have this pointer. We need to actually drag pointer over there to specify that's the pointer. So whenever we use the mouse wheel now, this will result in some non-zero values in the update, which is, every time the game evaluates, it's gonna get how much the mouse wheel has moved. If it's not zero, then we rotate this pointer by, this much, which is the move amount times speed times the time that has elapsed. Okay, go ahead and probably need to also move the camera. So we're seeing this thing. Okay, now play this. I can use the, well, you can see, well, it's not moving that much. I think maybe my value is too small. It could be too small. So I'm gonna go, oh, it's 0 actually. I'm gonna change that to 100 maybe. Give that a try. You can see now I'm rotating this box by doing mouse wheel rotating. 100 is too small. I'm gonna go for 1,000. Go ahead and play that. Yeah, now we got the rotating happening. The ball, I think we can make it simulate physics already. We just need to have a ground to keep it from falling down. So I'm gonna go to create 3D object and then cube again. Right, I'm gonna create the arena. Of course, I'm gonna have to zero out this. It's probably better to also zero out that. I can put the main camera also down to the player. That way, everything moves with it. Alrighty, so move this guy down. Play the game. Yeah. Alright, now next step will be left click to push the ball forward, right? The same thing, so I'm gonna go here and do that. So I'm gonna say if the mouse button is down, so input dot mouse lowercase mouse button get mouse button down. Okay, and then 0 means the left mouse button. Then we're gonna have to do something. The something we're gonna do is to push the ball forward. I need to know which one is the ball, right? So public game object bowling ball, which reminds me I should probably name that to bowling ball. And here I'm gonna say bowling ball dot rigid body, or get component actually. Get component rigid body, and then add force. The force will be added towards the direction of the pointer, so I'm going to say pointer dot transform. Not this pointer again. The pointer, I typed that wrong. Dot transform dot forward, or times a speed or force, slow force maybe. Right, and that's going to be something we have to also make. So public floats slow force will be equals to also 1,000, I think. Right, that's going to push the bowling ball forward by asking its rigid body component to add a force to it. Okay, the rigid body component is the one we add to the ball, right? If you recall, that's going to be the one that governs physics. Okay, all right, I'm going to go ahead and play this again, and then click. Oh, got an arrow. It doesn't know what the ball is. So I need to grab the player and drag the sphere to the bowling ball. Okay, go play this one more time. Click. You can see now we're getting the ball pushed forward. Very nice. And then moving on from there, I'm going to go have, again, Control D to copy this time in Unity. And just to build the same thing again. Control D one more time. Over here. And Control D one more time and drag it over here, make it thinner. And then I'm gonna create the part that's taking the, oh, I need 90. Collecting the pins. Okay, that's one on the back. Control D to have a copy, and this time I'm gonna rotate it 90 degree here, or 0 actually. Drag it down. Control D one more time. Go to make them all higher, I think. Maybe wider here too. Control D for that and rotate it 90 degree. Drag it over here. Okay, and then one more to be over here. Okay, now I need the pins. So I'm gonna go ahead and create another 3D object. I'm gonna use cylinder, right? And drag it over here. And I need to eyeball it, make sure that it's on the ground, more or less. Okay, I'm gonna rename this guy by pressing F2 and call it pin. And the pin will have also a rigid body component, just to simulate physics. And also I'm gonna go to the tag and then add a new tag and add a flat sign. I'm gonna say this is a pin. Save that, and back here to the pin. I'm gonna change the tag to pin, so that way we know that this one is having a pin tag. Okay, I'm gonna Control D to have a copy of that, and just keep on doing the copying. Now I have all the pins. Okay. Okay, now play the game. Let's see if we can push the pins away. I'm pushing them, but too weak. So I'm gonna go to the player and tweak that again. The throw force, maybe 5,000. And I think the pins are too short, so I'm gonna make them longer. Okay. All right, that's better. Okay, another thing I need to do is to give the ball the correct bouncing behavior. So that's going to be go to a game object, 3D object, somewhere here. Oh, assets, sorry, asset, and then create, and there's a physics material. Okay, all right, I'm going to call this guy bouncing physics material. And bounciness will be 1, so it's pretty bouncy. Okay, and we need to drag that to the sphere. Probably need to drag that to all the pins. Okay, so they all have that, you know, it has to be in there, right? And click on there and choose it. Oh, I'm doing that on the cube. These guys should have rigid body wise. Or collision here, yeah. Not all of them. I guess I have to do that on this one. Also, should have done that on all of them. Or I can make a prefab out of it. But it doesn't hurt to do that on them one by one. For now, because they're already done almost. That will make the bounce more accurate. Okay, alrighty. So after that, I guess I can make the bounce lesser than 1, maybe 0.8. Okay, and then I need to have the counter, right? So I can go ahead and do that with a new empty object. I'm gonna call this guy counter. Okay, for the counter, I'm gonna add a text mesh and drag it up. For the text mesh, I'm gonna type in score, column 0. Right, drag it forward so it's visible to us. And those shortcuts are the same, QWER, right, for the size and stuff. Maybe also there, right? And then we need to have a collision detector, right? Just like the collision box we have earlier in Unreal. We can go ahead and add another collision box collider here, right? Now I'm going to use the size of the score, which I don't really want it to. I can go to the edit mode and drag those dots to edit it. I want it to be, on the floor. So it's really hard to misclick those. So I'm not sure why it has to be this way. But yeah, go down and go down. Come on. Okay, got it there. All right. So now what I can do is attach a script also to the counter. So here, you can also right click here and click here and create C# script. You can call this guy counter, right? And you can see now it's already loading like this. Oh, it's not loading. We can go here, go to assets and double click here to open it. And then we can drag the counter, of course, to the counter here. That's going to attach it, right? So for counter, we just need to say whoever that's overlapping with it in the trigger, make sure that the trigger here is checked out, of course. Otherwise, it wouldn't do that. Okay. And then we can go here and say, create a new function called void on trigger enter, right? And it's going to automatically create the rest for you. And then I can say if other dot game object dot tag equals to pin. So it's pin. It's a pin. Then we do two things. First of all, game object dot destroy to destroy the other game object, right? And then we also wanted to increment the score, so we can create a private, which is not visible on the outside, private integer score. Okay, and then it's gonna start with 0 for sure. And then here we're gonna say score plus plus to increment score, and then we can say get component and then text mesh, and then we'll tell it to set its text will be equals to score column and then plus this score we're getting from the integer, right? And then to string to change it to a string. Okay. Go ahead and play this one more time. Right, you can see we're counting the score nicely, no problem, all good. All right, now of course we are almost there. We just need to fix the bugs of the you can only do it once and red mouse button to reset basically. So I'm gonna do that real quick. Okay, back here to the player controller. Now when the mouse button is done, we only need to do this once, right? So we can create a boolean for that. So we can say bool fired, right? And that's gonna be equals to false. Okay, I'm gonna say if that and fire not equals to false, equals to false, right? As both of those things has to be true to do this. Okay, and when we do that, we can say also fired equals to true. So basically it's only going to do once. Okay, all right, it's like the same as do once. And also we can also say if input dot get mouse button down, and this time we're going to use 1, and if that's done, then we need to use the scene manager, which we have to use that here using Unity engine scene manager, scene management. Or something. I'm gonna copy the I think it's called scene manager or something. Scene manager dot load scene, and we're loading our scene. Of course we haven't saved our scene yet, so I'm gonna press Ctrl S and also save it as game. Save that, and then back here I'm gonna use game here as well. Oh, so it's game, and then back here we can now try that. Right, and then I'm gonna right click. You can see now I'm back to the beginning. Right, very convenient. So one of the bug is, oh, we don't have that bug either, right? So yeah, this is basically done. Another something 20 minutes so, right, for the Unity to work. As you can see, even its coding, it's not that bad, right? Because it's using C#, which is a higher level programming language. It's not going to be as difficult to do. It's actually a pretty enjoyable programming language, and doesn't take that much, that long to learn. I expect you to take you half a year to get really fluent with it, but it takes a long time to really get used to programming though, on a very good level, because it takes practice. Okay, just like anything. All right, that's a direct comparison between Unreal and Unity to do the same thing. As you can see, the difference is not that much, right? The difference is different syntax, but the algorithm are almost the same, right? Only do once and then add impulse, right? In Unity, it was add force, but at the end of the day, this is that. It's just in different form. Okay. Alrighty. So one last thing is how we do this in C++, which is how Unreal does its coding, instead of visual scripting with Blueprint. Okay, let me show you that. Right. So just to keep things clean, I think I can get rid of all these things we have done, but we can keep the environment. Right. So I'm gonna go here and then go to, before I do that, I'm gonna go here to the project settings. I'm gonna use not project settings, editor preferences. I'm gonna go to the source code. You can see my source code editor is Rider. That's gonna be a IDE designed for Unreal Engine, or one of the versions, I guess. There's another version for Unity as well. I'm not gonna use Visual Studio because it's kind of like really slow with Unreal, so I'm gonna use Rider here. Okay. All right, and then I can go to engine content or content, right click, and then new C++ class. Again, Pong, just like we did earlier, right? Next, I'm gonna call this guy player Pong, bowling player Pong, and then create class. Okay, that's gonna take some time to compile the C++ code. And because this is a low-level programming language, it's not running on any virtual machine. It takes time to compile, right? And not like things in like C#, it's not. It doesn't need to be compiled to machine code to be run. It's compiling at runtime, and it's running on the virtual machine. It's like you're translating the source code into binary code in real time when you're running it. So it does have some performance issues. In C-Ray, C++ will always be faster than C#, if you know what you're doing, of course. But nonetheless, when it comes to like how fast the development is, C# wins hands down. It's just really fast to code compared to C++. You will see that in a matter of minutes. Okay, so now it's opening this thing called Rider. It's the IDE. It's basically another equivalent of Visual Studio. Right, they're all code editors. Right. And here you can see not only that, and because it's C++, it's also having to index everything and takes a while, a few 2 or 3 minutes I think for this to go through, because it has to check every symbol. One thing Unreal does very different compared to Unity is it's loading the Unreal project. Every class, every piece of code in the engine is valuable for you to review. So you can look at anything if you don't understand it, right? Unreal is not very well documented on their website, but if you really take a look at the actual source code, everything is very well commented. Their documentation is copying these things into the web, which is kind of like embarrassing. I think more explanation or some examples would be better, but it's pretty difficult. pretty difficult to learn without the guidance. You have to really read the source code. Now, another major thing that's different here is that in Unreal or C++, you have two files, header file and CPP. Header file is like the content of what's available for this particular object. You can see all the functions like begin, play, and tick. Tick is actually the equivalent of the update we're doing here. You can see there's a comment above them. Those green ones are comments. They're just for you to read, right? You can see this is updated is called once per frame, and this is called every frame. Basically the same way of saying the same thing, right? So at the end of the day, you are having very similar systems compared to those two, right? Okay, so let me start coding here. Okay, for the player, I need to add a few things. First of all, I need to add that pointer thing, right? So I'm going to say u property, add it anywhere, blueprint, read, write. Read only is fun too. And then I'm going to say use static mesh component. I'm going to do a using component first for the root. You have to type in a pointer here, a star here. This is basically saying this is a pointer. Pointer is something unique in C++, which is actually an empty slot, an address to remember a memory on the memory card. So it's basically empty now, and we have to actually give it something later on. You'll see. I'm gonna do another u property, add it anywhere, blueprint read only, and this one will be use static mesh component. You can see I'm just using auto completion all the time because the naming of those variables are really long. And this one is gonna be my pointer. And then keep on going. Maybe I can copy that, Control C, Control V. And this one will be my bowling ball. Okay. And then just to keep on going, I need to know the speed. I know I need that. So for that, I need to actually add it. So I'm gonna say blueprint read write. Okay, and then this is gonna be float speed, pointer speed. Okay, now keep on going. I need another one to determine the force, right? Control C, Control V again. Let's have a copy of that. And this is the throw force. Now pointer speed will be equals to 10.f as float. Throw force will be maybe 10,000. Okay, so this is going to be the thing. You can see this is the same we have in here more or less in the player controller, of course, right? We have the pointer, we have the bowling ball, pointer, bowling ball, root. We don't have root here, but the root is basically the thing on the outside. Speed, I call it pointer speed, throws force, right? And fire equals false, right? We can do that here too, actually. So this is going to be something internally. I don't need to make it a U property if I don't want to see it in the editor. So bow fired equals to false. Okay, now this is not creating them yet. We have to, those two are created without pointers, but those guys has to be created in the CPP file. Let me hit Alt O to go switch to the CPP file, or you can click on the tab here. I'm going to say root component, or root will be equals to create default subobject, and then use scene component. And then I need to give it a name, which is root conf, maybe, whatever you want to call it. This is going to be the name appeared in the editor, right? And then moving on from there, I'm going to say set root component to be this root, which will make it to be the grandparent of everything underneath this object. And then I'm going to say the pointer will be equals to create default subobject one more time, and this time it's a static mesh component. Right, and then pointer as the name, and then we have also the bowling ball will be equals to create default subobject, and then use static mesh component, and then pointer, not pointer. This is a bowling ball. Okay, And then we need to set up a few things, like if you remember in Unity, we set up the physics thing, right? So we're gonna say bowling ball, you're gonna simulate physics. Set simulate physics will be equals to true. As you can see, this is basically English language with a few syntax you have to take care of. So don't get too scared about programming, especially when you have a game engine. You're not dealing with too much nitty-gritty under levels raw performance thing. You're basically doing a lot of game logic. So if your logic is clear, you learn some algorithms, you are fun, right? Bowling ball, simulating physics. Pointer, however, set collision response to all channels to be ECR. Ignore. ECR stands for enums. CR means collision response, right? Ignore that. Okay. I think that's it. That way the pointer is not colliding with anything. Bowling ball is simulating physics. Okay. And now we need to set up some inputs, right? So I'm gonna say underneath this function called set up player input component, I'm gonna say player input component dot band axis. Okay. And then the axis we're banding with is gonna be called mouse wheel. This is something we need to define ourselves, okay? And then it's going to be bound to this object with a function that we also need to define. So a bowling player pawn mouse wheel moved maybe. Okay. And you have to add a semicolon on the end of every line of code. Okay. Now I'm gonna press Alt O. I'm gonna copy that here first. Alt O to go back, and here on the very bottom I'm gonna create a U function, which is gonna be something we can call. Oops, I don't need that. So U function, and then I'm gonna say void that, and then float speed mouse amount, or amount should be fine. Okay, and then go here Alt Enter, and then enter again to create the implementation. It's going to create the implementation here in the CPP file already, and then also have everything ready for me to type in. So I'm going to say, okay, I need to know delta time, right? So I don't have to actually create a variable for that. So when mouse wheel is moved, we can directly tell pointer to add local rotation, right? Rotation will be rotator, and then we're gonna say 0, 0 for those two directions. For the Z direction, we're gonna calculate it, which will be amount times get world, get time second. Okay, and then we're gonna also times the speed. Pointer speed, right? We have created that already. Okay. All right, and then we can also do player input component and band action this time, and we're gonna say fire, and then IE pressed. So that's when the fire button is pressed. We're gonna call a function a bowling player pawn throw ball, maybe. Again, that's something we have to also create. So I'm gonna copy that back here to the header files. Another U function, void, void, and then that, and then Alt enter to create it. Yeah, you can see it's not, with this ID, it's not that bad. Otherwise, you have to flip it into files a lot and do a lot of things, copy pasting. So what happens before is that when the mouse wheel moved, right, it's going to call this mouse move function, which is here. It's passing in how much it's moved. We're going to use that to time to the delta time and time to the pointer speed. Now here's throw ball, which is going to say bowling ball, add impulse to it. Okay, and the impulse will have a direction, which is the direction of the pointer. So we're going to ask pointer get up vector, right? And then times the force, so throw force. Can see we're doing the same thing more or less compared to Unity, but we can compare those two things. You can see here in Unity, everything is handled in update, including the inputs, right? So we got the mouse wheel movement here, but here in Unreal, it's banding to the mouse wheel first, and then it's calling a function, and that amount is passed as an argument here, which we use. But at the end of the day, the actual thing, which is pointer, transform, rotate, here pointer add local rotation, that's the same thing. We're rotating the pointer now, and we're passing in the amount the same way, right? Speed times delta second, and then the mouse will move amount, right? Those three things are those three things. So you can see even the syntax and the structure is different. When you boils down to the actual code, it's gonna be only just different named functions, but very similar operation, right? Bowling ball here, which is fire. You can see bowling ball, get component, rigid body, add force. We're just adding inputs here, right? This one has a little bit more stuff, but you can see this is basically adding something, a force, right, to the bowling ball. All right. Of course, I forget to do that fire check, so we can do that. Okay. If fired, if not fired, fired equals true. True. Okay, and here for this guy, I think I can use this shortcut, Control Shift Alt up, back. Doesn't really work. I'm gonna copy that over to here. Okay. Alrighty. Oh, this rotator is actually F rotator. Sorry about that. So it's gonna rotate it. Okay. And then while we're at it, maybe we can also do that and games restart game stuff, right? Player input component, ban action one more time, restart maybe. Okay, and then IE pressed, IE pressed, and that's and ampersand a bowling player. I'm not doing throw ball this time. It's gonna be restart game. Okay. Right, which we don't have. Again, the same process. I'm gonna copy that. Alt O to go to the header files. Another U function. Right. You can see I'm quickly going through the same thing, reconstructing all the code in C++. Of course, this is a little different, but it's okay. Right. So we restart game. What do we do? Well, we used another class called uGamePlayStatics. uGamePlayStatics. Okay, and then column, and then load or open level. Yeah, and the level will be called game. We haven't done that. We have done that already. So just open level game. I also have to specify which world we're working in. So this should be fun. All right, that should be it. That should be everything we need to do for the player, right? Now, of course, I showed you how every step works in Unity, but this is how everything just laid down right away from beginning to end. And then we're gonna click on the compile button in Unreal just to compile it. Okay, that's not automatic. In Unity, when you save it, Unity detects that save and it's gonna compile it automatically. Unreal, you have to click on the compile. When the compile is finished, I will have in the C++ class, we will have our bowling player. Right click on it. I'm gonna go create blueprint class based on that. And call this guy BP bowling player pawn. Okay, that's gonna open the editor for me. Okay, and sometimes it doesn't really give me the things I did. So when that happens, I'm gonna save the scene, close the editor, save it. I have to run it here to really make that connection. And you just have to do it once. The next time it should be fine. Okay, you can see now the engine is restarting, which shouldn't take long. I'm gonna go to the game level, open it, and then I can go to my BP bowling player pawn there and double click to open it and open the full blueprint editor. You can see now I have the pointer and bowling there. Right, this is just mimicking the one we did earlier. right? For the camera, we can also add it in the editor in the C++ code, but you can also just add it in here real quick. I don't think that should be or need to be exactly necessarily done in the coding. But here you have to also define the cone here. Otherwise, you have to load it in the code, which is the big pen. You have to really copy the directory. Notice that in Unity, we did all those things in the editor, right? In Unreal, we create them in the C++, but the artists get to define what they are in the static mesh slot. Okay, compile and save that. So this is my bowling ball pointer. Oh, this is actually the bowling ball. Sorry about that. I'm gonna fix that real quick. So this one is the cone. This one is the ball. So change it back to 1, 1, 1, and change that to sphere. Sphere. Okay. And for the pointer, I'm gonna rotate it down, make it longer and smaller. All right. Okay. Now to make this all work, you also have to make sure that in the project settings, the input is set it up properly, right? So here, we don't have any input. Now before in the blueprint, we set up a few. If I can show you that. Here, you can see they're just right here, but it's not recommended to do it that way actually, especially when you're doing something more serious. You want to actually name your actions. So I'm gonna go to the project settings and go to inputs. I'm gonna go create one axis mapping, and this is gonna be the mouse wheel, right? That has to be having the same name we defined here. So I'm gonna copy that mouse wheel and then put it in here, right? I'm gonna find mouse wheel axis. For action, we have 2 actions, right? Left and right click. I'm gonna add 2, and here basically we need to copy and paste the naming. So fire and restart. So this is fire and this is restart. I'm making sure that I'm getting it right. Restart. Okay. Fire is mouse left mouse button. Restart is right mouse button. Right mouse button. Yeah. So we got all those things. I'm gonna close that now, and we can drag our BP bowling here. Okay. I'm not sure why those things are farther away. Let's double click to open that and take a look. Their direction, their position shouldn't be different. Let's see. Yeah, I'm not sure why. Zero that out. Grab this guy and zero that out. Okay. Alrighty. So I'm gonna go grab the player and put it down there. Now, because this is a new one now, I also have to do the same thing, which is auto possessed by player 0, right? Compile and save that, and go ahead and play the game. Oh, I don't have the camera, so I'm gonna press Ctrl E, add a camera here. The same deal. Again, this camera can be created in the C++ code, but it's up to the artist to move it somewhere else to get the correct angle. Play that. Let's see, now we're changing the direction and we're shooting, right? That's all good. The shooting, of course, the speed is not fast enough. So let's see. Throwing force, that's not even enough, huh? I'm gonna give it one more 0. Okay. Maybe even further, but you can see how we can use C++ to get all these things done, right? Play that. Okay, that's pretty crazy. So maybe lower that down to 5 instead of 10. Compile and save that. True. Okay. Alrighty, and then we can move on to the pins. I think pins are easy. So all we have to do is create a new class. And this time it's going to be actor, the same thing. We call this guy pin, create class. For pin, we just need to have a static mesh, and we just need to make sure that it's simulating physics. Okay, you can see creating a code is also a little bit slower in Unreal Engine, right? Because it's C++, it takes time to compile. All right, so yeah, we have the pin, and I'm going to say view property here. Edit anywhere, blueprint, read, write. Category, oh, I don't need to have category actually. Use static mesh component, pointer, pin mesh. Okay, and Alt O to go to the header files. I'm gonna say pin mesh dot equals create default subobject and use static mesh component pin mesh. Okay, save that. And oh, and one more thing, I want the pin mesh to simulate physics, so pin mesh dot simulate physics equals true. And that's pretty much all we have to do here for the pin, right? In the coding part, all those things can be done in Blueprint. As you can see, this pin is probably going to be easier to just be, you know, a Blueprint instead of a C++ class, because there's really not much code to do in there. But I'm gonna go do it anyway. Right click and create Blueprint class or base, and BPC pin blueprint from C. Okay, and then create that. Okay, all right, now I have the pin mesh. I'm going to change that to a cylinder, shape cylinder here. And of course I can do something. I cannot do something here actually. So I'm gonna go just drag it here, and then this is where I can start to drag things around and change the size and stuff. Some nice touch of Unreal is that when you drag something on the flat plane, it's gonna make it stand on the flat plane. Okay. All right. Now I can hit those things down. You can see we're gradually mimicking everything now in C++. So one more thing, which is the counter. So I'm gonna go ahead and do that. That's gonna be another actor, right? And then will be counter and create class. All right, now we have the counter here, right? For the counter, we don't need any visuals. Oh, actually, we need one visual, which is the text, right? So let's do that. You property. I think I can create a root first. So edit anywhere, blueprint, read only. Use sync component, root. Then I need to create another U property. Same thing. And this time it's going to be a U box component for the collision. Call it trigger maybe. Trigger box. And then another U property. Again, same thing. And this time it's going to be U text render. I forget that thing. There should be something here in. If I can look for that old BP player pong here, right? Oh, not there. Actually, the counter. It's called text render component. Okay, if you forget something, you can do it in there. Text render component, view text render component, right? Pointer, score display maybe. Right, those three things are the things we need, and we need another variable which is the actual count. So that's going to be something private int count score equals to 0. Okay, all these things. Now Alt O, we're going to set up our stuff, right? So root equals to create default subobject, use scene component root, and then the other one will be trigger box, right? Equals, they're all calling the same function to be set it up basically. Box component, and then this is another one. Will be, let's see, our score display goes to create default subobject. You can see how useful this auto completion is. It's just really fast compared to just type everything from scratch, right? Some people may argue you shouldn't do this, especially for beginners. Let them do the coding on a text editor, like the note. Yeah, I think, yeah, that's fun. But when you're doing real production, I think it's just really taking too much time to type, especially for a big engine like this. You have such long named functions. Okay, so I don't think it's meant to be done that way. All right. So one more thing we need to do is a collision event, right? So I'm gonna say virtual. This is void notify actor begin override. This is gonna override a function that's already exists on the lower level, and you're overriding it to it, and it's gonna be called when there's something overlapping with this actor, no matter what component it is, which include our trigger box, alt enter, and then generate implementation. Okay, all right, and then we're gonna say if the other actor we're overlapping with, the other actor that's overlapping with this, dot get class, right? As class is equal to, actually is child of another class, which is the pin class, a pin static class. Okay, the a pin is not in here. We have to include it. A lot of include are done for us automatically, actually. But we have to do this one manually. Include a pin actually. So you have to include that to be able to reference to our a pin class, right? So basically, what this says is if the other actor is a pin or a child class of pin, because our BP pin is the child class of pin, so we need to do that. If the other actor is is the child of that. Then we're gonna have to do something, which is first of all destroy that. So other actor dot destroy, right? And then score plus plus to increment that. And then we're gonna say score display dot set text f text from and say score plus column plus our other score, right? Upstream from int, okay, score. So basically we're putting all our information together with the score column and then the actual score from int into a string, and then pass and convert it into a text, which will be decided to the text. Okay. All right. I'm gonna go ahead and compile it. Okay. You can see C++ is definitely taking longer. It's the longest time taken to do this, right? It's almost 30 minutes now for that part. Oops, got a warning. Show that. Text score. Set text score display. Did I make it private? Nope. Go back here and let me just read that again. I can see that in here, I think. Yeah. And what does it say? Or maybe not. Let me take a look at that again. I think I don't have to have f text. I believe it's able to do that for me. Let's see. Score plus that. Okay, let's take a look. Yeah, that works. So I'm gonna go ahead and play. Oh, I don't have that yet. So I have my C++ class with my new counter, create a blueprint class based on that. I'm gonna call this guy BP counter now, BPC, and create that. Compile and save it. I'm gonna drag it over now to the viewport. I'm not sure why they're always having that offset. I'm gonna go ahead and having to zero that out for the trigger box and the text. Okay, and then I can start manipulating those things by dragging those things around. Trigger box will go down there. And the text here need to be flipped and bigger. And here I'm going to change it to be in the center, I guess. Yeah, that's better. And then we can change it to score already. 0. I'll drag it down. Play this one more time. Maybe a little bit lower than that. Alrighty, go there. You can see now the scores start to add, which is working. Right mouse button to go back. Right, everything redone in C++. Okay. Alright, that's both engines introduced, and Unreal introduced twice with C++ and Blueprint, all doing the same thing. The main takeaway here, I think, is that you can see if you know one of the engines, like Unity, for example, transferring to Unreal, you just have to learn a little bit more about C++ and then how to find the equivalent functions, right? Rotation or add force, load scene kind of thing, right? On the other hand, if you don't want to do coding at all, you don't want to type in anything, you can use the Unreal Engine Blueprint, which I believe in Unity there will be a visual scripting language coming out soon, 2021 sometime. So you could also wait for that. But for now, the best one will be Blueprint. Okay, there's other plugins like Bolt something, right? Playmaker in Unity that does also visual scripting. One of the nature of Unity is that you can have the asset store here. You can get a lot of very good assets. Some of the paid ones to expand functionality to Unity has the biggest library in here. Okay. On the other hand, Unreal has a much complete package, so you probably don't need to get any plugin to get things working. Another benefit Unreal have is it does support some very heavy, very good libraries like Megascan. It's free for Unreal users. Okay. On the other hand, Unity has a bigger community and bigger documentations, better documentations on this coding. And whenever you have a problem, you can probably find an answer. But Unreal is getting close on that too. the community is getting bigger and bigger as well. Choose one of the engines. I think you can based on what you want to do in the future. If you want to work for like a big studio for like a very polished high-level games, you can go for Unreal, because that one is more suited. This Unreal is more suited for games like that, like things like Final Fantasy VII, right, or Mortal Kombat, right? Those are polished games and PC games, right? Big studio, multi, a whole lot of people working together, kind of like game. Then Unreal is your choice. Of course, when you're working for some studio like Naughty Dog, you will be using their own engine, but learning Unreal for that type of game is better than learning Unity. On the other hand, if you're liking more like mobile indie games, smaller scope games, Unity is your friend. You can see Unity is the one that takes the least time to develop this game, right? It's literally going to take the lesser time to develop a game because of the C#, right? Even compared to Blueprint, you can feel that Blueprint is not that faster, if not slower sometimes. And C# is really good, and Unity set its way in the very beginning to be very user-friendly, especially for programming. It's very easy to use in that manner. You can see in real practice now, and this is a solid proof that why Unity is faster and is popular between programmers, because it is faster to write code, right? Now, of course, that's based on what kind of programmer you are. If you're a super professional programmer, that you know C++ well, you know how to do really good and efficient coding, Unreal offers unpromised flexibility. Why? Because you can go here and you can check the actual, here, let me show you. You can hold it down, control and click on maybe the actor class. You can go there. This is the full source code of the actor class, all available for you to read. If you find anything you don't know why it's not working for you, you can dig into the source code and you can pick at it, and then you can know what's going on. Everything is very well documented, right? This is probably the world's best programmers doing their job here, right? So you can learn a whole lot here also. And also Unreal has even a not open source, but a full source code version that you can get, and you can use that to develop your game as well. Then you can make adjustments to Unreal Engine, like to actually change it to make it suit your needs, right? Unity doesn't have that advantage unless you somehow negotiate with them privately. There's no plan for that. You don't have access to the source code. Something comes out and it breaks, then you have to rely on them to fix it. And also when it comes to multiplayer games, Unity is a little behind on that. Its multiplayer support is not very good. But again, those things, I think they're going to be fixed in the future at some point. Okay, if you're making your first game, multiplayer is probably not going to be in your mind that much. But if you want to do multiplayer games, Unreal is really good on that. It's able to support a massive amount of players. Fortnite is kind of like that, right? So yeah, it's battle-proofed in this case. Okay, so that's my analysis on both engines, comparing and developing real games not real games, but examples on how they would look like when you're building your game. Of course, that's just scratching the surface. We didn't even talk about animation, but generally speaking, you could expect more complete features in Unreal. Unity have its things, but by comparison, right, it's catching up on many of the things, of course, but by comparison, Unity offers a much more complete package compared to Unity. But again, asset store will be a big compensation to the lack of Unity, the lack of features sometimes in Unity. So you can get good result in both engines for sure. All right, that's it for this video. It's like 1 hour and 33 minutes, right? So I guess I think that should be enough for you to get a taste of how those two engines feels like, and make your own choice. Okay, don't listen to anyone, don't listen to me. Sometimes maybe some of the things I said even can be argued about, feature wise, whatever, right? it's a never-ending battle, but that's also a good battle, right? When people keep talking about two engines, the competition will drive the two companies to do the best they can, right? And the only winner will be the users. Okay, that's it for today. Thanks for watching. See you next time.